In this problem, we have a set of 3 resistors that we've been asked to add together. And then once we do that, we're going to be able to find voltage V1. So to add resistors, we have 2 equations, in series and in parallel. If we look at this problem, we'll see that the current can go and split through any of these. It's not forced, so these are not in series, they're actually in parallel. You can prove that they're in parallel by saying I can find a loop with just these 2. I can find a loop with just these 2. I can find a loop with just these 2. So all of these elements are in parallel. An easy way to do it as well is to identify that we have a node up here and a node down here. Everything starts at the same node and ends at the same node. So they are in parallel, so we're going to use this equation. That is going to be 1 over the equivalent resistance. Make sure you do the reciprocal here. Equal 1 over R1 plus 1 over R2 plus 1 over R3, since we have 3 resistors. R1 will be 40, so 1 over 40 plus 1 over 8 plus 1 over 10. And then we want to look for a common denominator here. So conveniently it is that 40. So this will be a 1. For this one, to make this to a 40, I had to multiply this whole thing by 5. So 5 on top and a 5 on bottom makes the bottom a 40. So we'll get a 5 here. To make this into a 40, we have to do a 4 on the bottom and a 4 on top. So 5 plus 4 plus 1 is 10 over 40. So we are not done. Make sure you don't make this mistake. It's not 1/4 or 10 over 40. You need to flip this thing. So RE will be 40 over 10, or 4 ohms. Now to use this, we can redraw our circuit with our equivalent resistor, which is 4 ohms, and we'll relabel our voltage 1. So these are the exact same circuits. And then we want to find V1. Since these are in parallel, we know that V1 is also over here. Again, they share the same top node and the same bottom node. And then we know that 2 amps will go through this. So we could do a KVL, we could do a KCL, but we're just going to use Ohm's law in this case. Ohm's law says that V is equal to IR. You'll see that we are satisfying passive sign convention here. Our current's going to be going down. Our polarity is positive to negative, so it is passive. So we don't have to fix any signs. So V1 will be equal to 2 times 4, our resistance, which will be 8 ohms. Now, if we wanted to prove that this and this are the same, what we could do is a KCL at either the top node or the bottom node. So we would have, say, 2 amps entering, and then we would have V1 over 40 leaving, V1 over 8 leaving, and V1 over 10 leaving. And then we could combine all of those. So again, you'd have V1 over 40, V1 over 8, V1 over 10. You'd end up with this fraction again. So, oops, and that is not ohms. Let me fix that. 8 volts.